Hey everybody, so we're going to be talking about the Hinge theorem and its converse. Pretty much, this is now going to be doing inequalities with two triangles. You're going to go ahead and fold your notes so they look like this. And I folded the examples page up to right under the Hinge theorem and the converse. And then folded the top part down. It does overlap a little bit, and I'm sorry about that. All right, there's something I want you to put on the front of this. And this is what's really going to help you kind of understand what the Hinge theorem is. Because the Hinge theorem, you're using it every single day and you don't even know it. So the wider the door is open at the hinges, the larger the opening is to pass through. And think about it. If you don't want to let somebody in, you only open the door a little bit of the way because there's not enough room. But if you've got something in your hands or you're just kind of walking through, you open the door largely, and you have a wider opening. And that's kind of what the Hinge theorem is talking about. So this is saying that if two sides of one triangle are congruent to two sides of another, so that has to be there. It's part of your hypothesis, and it's a necessary requirement for you to apply the Hinge theorem. And then the included angles are not congruent. Then the longer third side is going to be opposite the larger included angle. Pretty much, it's two triangles using the side length and angle measure theorems. Because that means if the measure of angle A, if this one is bigger, say this is, I don't know, this is the bigger one. And that means this is the smaller one. Your door is not open that much. Then BC, right there, which is opposite of it, is going to be greater than YZ, which is opposite that. Pretty much, the wider the door is, the wider your entrance is. All right, the converse is also true. All right, so if you're opening right here, and again, you are going to have the two sides congruent to another triangle of the two sides of another. Third sides are not congruent. Then the larger included angle is opposite the longer third side. Pretty much this time it's saying that if the side length is larger, then the angle opposite it is going to be the larger one of the two. So BC was larger. That means angle A was going to be larger than angle X. Now, when you think about it this way, look, if we've got this door opening, notice when I first open it, it's not as small. But when it's all the way open, the opening to get through is larger. So this one right here, your opening length is smaller than this one, which means your angle right here is smaller than that one. All right, so let's use it with some examples. And all we're going to do is we're going to use our less than and greater than to complete each statement. So let's look at this one. First, we've got our two congruent sides. And the included angles are not congruent. So we're going to look opposite them. And EF is with the bigger angle. That means EF is going to be greater than NP, since angle D was greater than angle M. All right, we're going to apply the same thing here with our angles. And this is, of course, using the actual Hinge theorem, not its converse. In this one, you'll notice QR is actually larger than CA because 81 is more than 68. In number 3, you have to remember that JL is reflexive, and it is, in fact, congruent to itself, which means that we can, in fact, use 60 with HL and 55 with the KL. KL is going to be smaller, which is why my inequality is pointing at the smaller one. It's kind of like a really bad bully where it's just like, heh heh, and it's always pointing at the smaller one. I know. It's kind of corny, it's dorky, very 1980s sitcom movie kind of thing. Yeah. All right, so let's do number 4. First, we have to figure out our two congruent segments and their included angle. So we've got AB and XY. And if you need to draw your circle to remember which ones are going to be corresponding, you can. And YZ and BC are also congruent. So then we're going to be looking opposite those angles and opposite those sides, and notice that XZ is greater, which means AC is less than, and angle B is going to be less than angle Y. All right, number 5. All right, we've got a reflexive property into play with MP. Notice MN is smaller than MQ, which means that NPM, this angle right here, is smaller than QPM, which is this angle right here. Always look at what letters they're going to be giving to you. All right, number 6, reflexive into play again, with DB being congruent to itself. Angle ADB is going to be less than angle CDB because 35, the side length opposite it, is going to be less than 37. This is using the converse of the Hinge theorem. And then just like what we did in our last set of notes, you can create an inequality to figure out what this X value is. Now, I would go ahead and set it up like this already. And remember, this is going to be your smaller one. And this is going to be your larger one. And then you'll want to notice that 15, of course, is greater than the 10. So I set it up like that. Now, what you do want to remember is no matter what you do, the smaller one, all of this has to be more than 0. So I did 5x minus 20 is greater than 0 first. Added the 20 over, solved for x, and I got x has to be less. Oops, I swapped my signs. X has to be greater than 4. So we're going to drop that smaller number in. Then I'm going to use this right here, and I'm going to write my inequality saying that 5x minus 20 is going to be smaller than 60. All right? So it has to be smaller than this, which means that we're going to add the 20 over, and you get 5x is less than 80, which means x is going to be less than 16. So your 16 goes here, and this would be your answer. And if you're having issues seeing this first set of inequalities, here you go.